Okay, so that's thermodynamics. Is it spontaneous or not? Now we're going on to kinetics and activation energy. So just because it's spontaneous doesn't mean it's going to happen by itself, because it still has the hump, right? And so now we're talking about kinetics. How fast is your reaction going to happen? Thermodynamics and kinetics are two separate things. Thermodynamics has to do with spontaneous. Is the energy of the products lower or higher than the energy of the reactants? Kinetics is how fast are we going to get there? Okay, all right. Okay, we were talking about enzymes before, and so an enzyme is a catalyst. So what the catalyst does is it lowers energy of transition state. What the heck? I'm sorry, I mean, hee. But it does not change the delta G. It doesn't change the Gibbs free energy. So no matter what, your energy of your products and the energy of your reactants are going to be the same. So this difference doesn't change at all, no matter how you get there. But a catalyst does reduce this activation energy. It has a kinetic effect, no thermodynamic effect. Okay, redox, yay! Oxidation and reduction. I don't know if you liked this when you did this in Gen Chem. It was kind of confusing for me personally. Let's see. So plants are photoautotrophs, animals chemoheterotrophs. So basically what the book was talking about in this part is just that all energy comes ultimately from God. But no. So all energy comes from the sun. Solar energy gets converted into like food for the plants, so the plants can grow. Good night, Dad. And then love you. And so that's through redox reactions of like transferring electrons and stuff, and then that energy gets so that's where it comes from the sun. So plants are photoautotrophs, and then the animals eat them, so that's chemoheterotrophs. So then there's more oxidation reduction reactions going on when we eat the plants. So stored in reduced. Okay, so the energy is stored in the reduced form, right? So reduced is when it gains electrons, so that's the energy stored, and then when it oxidizes, that goes into the oxidized form is like carbon dioxide and then ATP. Blah blah blah. And it says ATP drives energetically unfavorable reactions of the cell. Non-spontaneous. Those are the reactions that have a positive delta G, where the products have a higher energy than the reactants, right? And so ATP is going to be coupled with those reactions, because ATP becoming ADP, right? It's losing that phosphate group. There's a lot of energy in that bond, so when it reduces that one has a very negative delta G, and so that can make the positive delta G reactions go. So these are the basic energetics of life. All the rest is detail. Okay, so oxidation is loss of electrons, reduction is gain of electrons. You remember oil rig. Oxidation is loss, reduction is gain. But in the MCAT, you don't have to think about the electrons moving so much, because you can just you just remember these things. And this is true in organic chemistry too. If there's a gain of oxygen atoms, that's oxidation. So think of that. Oxidation, oxygen, gaining the oxygen atoms. And then also the loss of hydrogen atoms and the loss of electrons is all oxidation. Whereas reduction is when you lose those oxygen atoms, or you gain hydrogen atoms, or you gain electrons. So when you see things like, when you see that there are more bonds being formed to hydrogen, then you know that something is being reduced. Like, for example, when like the cysteine amino acid groups, if they had a disulfide bond like this, but then when they were inside of the cell, the inside of the cell is a reducing environment. So what's going to happen is that they're going to be reduced. They're gonna break that disulfide bond. And here's the rest of the polypeptide. Because they've been reduced. This hydrogen has been added. This gain of the hydrogen atoms. So that's an example of reduction. A redox pair, you know about this. Obviously, if something loses an electron, something else has to pick it up. So one atom's reduced and one atom's oxidized. They always come in pairs. Catabolism versus anabolism, which we learned in anatomy. Catabolism is to break down, and this is normally oxidative. Catabolism is generally oxidative, and that kind of makes sense when we see that energy is stored when certain molecules are reduced, when those electrons are added, when those hydrogen bonds are made. Like that's where energy is being stored. So that's kind of building up bigger molecules to store energy. So that's anabolism. Anabolism is building up, and it's generally reductive. And then catabolism, we break something down, and that's an oxidative process. So oxidative catabolism, when we break down glucose by oxidizing it. So you've seen this so many times. But here's the glucose molecule, and here's the oxygen that we're using to break it down. And then we can see that these carbons are forming two bonds to oxygen, and so these carbons here in glucose are being oxidized, and these oxygens here, they are gaining hydrogens, right? This oxygen has formed two bonds to hydrogen, and so these oxygens are getting reduced. Okay, so food energy goes to ATP, which is used, or ATP can itself generate storage molecules like glycogen or fatty acids. So basically, when bonds break, they release energy, but it takes a lot of energy to form bonds, right? And so ATP is used to form the bonds in glycogen and fatty acids, because that takes energy to build those molecules up. So ATP is the exergonic spontaneous reaction that has to be coupled to these endergonic reactions of making all these bonds and building bigger molecules. That does take energy.